Second problem. Solve the initial value problem L di by dt plus Ri is equal to 0, where we denote I of 0 is equal to I naught. Here I or L are respectively the current, resistance and induction in the electric circuits. Here initial value problem means after solving the given differential equation we can apply the initial values. So such type of solution is known as initial solution. Okay, here we see how we are going to solve this problem. Solution. Here in this problem given differential equation is L di by dt plus Ri is equal to 0. Now this method is variable separable method. So we can separate the variables. Here what are the variables involved in this differential equation? I and t. So take I and di terms to one side, t and dt terms to other side. That is, we are writing separating the variables. Separating the variables. Now L di by dt is equal to minus Ri. Okay. So after that we are going to separate I and di terms to one side. So here I term is or means I function is right hand side of the equal to. So taken it to this side, that is 1 by I into di is there. Here also L already here, so that's why we write as it is L 1 by I di is equal to minus R. Here dt can be transformed into right hand side dt. Okay, here L also can be transformed into this side, that is 1 by I into di is equal to minus R by L into dt. Okay, now clearly this is variables are separable. After separating the variables, we can solve this equation by applying integration on both sides. Integration on both sides. Integral 1 by I into di is equal to, here the constant value, there is no t terms in this, so that's why this is constant. So R by L integral dt. That implies here denominator value is I function. Here the I derivative is 1. So which is of the form, here we are going to write the formula, integral f dash of x by f of x into dx is equal to log mod f of x. So denominator lo ఉన్న ఫంక్షన్ యొక్క డెరివేటివ్ న్యూమరేటర్ లో ఉంది కాబట్టి, అంటే I యొక్క డెరివేటివ్ రెస్పెక్ట్ టు I 1 కాబట్టి, సో ఇక్కడ న్యూమరేటర్ లో ఉంది డెరివేటివ్. సో ఈ ఫార్ములా కంపల్సరీగా ఉన్నట్టే, కాబట్టి we have to apply ln of mod f of x. Now that implies ln of mod f of x means here I mod ln of mod I is equal to minus R by L. Here, what is the integral of dt? Derivative integrals are inverse to each other. That's why here derivative is cancelled by integration. We have only t. So after the completion of the integration, we add the integration constant c. Here is c is arbitrary constant or integration constant. Now this can be written as ln I is equal to, without loss of the generality of this value, we can write ln e power minus R by L into t. Plus here c means arbitrary constant, that's why we can change the c to any one of the form. So here we write ln c in place of c also. Here, why? Because we are going to write this value into this. Is it equal or not? So exponentials and logarithms are once inverse to each other. That's why both are cancelled. Then we have the value. So e power or ln e power x is equal to x simply. By using this formula, we can write this value into this. So that's why ln I is equal to, here clearly this is log a and this is log b. Log a plus log b. What is log a plus log b? Log ab. That's why ln e power minus R by L into t into c. So here we write c here. Log ab. Okay. Now here that implies, so on both sides ln is there, so we can cancel ln. What is the remaining value? I is equal to c e power minus R by L into t. This is our general solution. But in this problem, initial conditions are also there. What are initial conditions given? I of 0 is equal to I naught is given. I of 0 means, here I of 0 means 0 is the value for right. Given that I is equal to 0 when t is equal to 0. That is the meaning. So we apply these values into equation number 2. So right, I of 0 means I0. So I0 is equal to c e power minus R by L into t means here 0. That is equal to c e power anything power 0. E power 0 value is already we know 1. So that's why here we write c only. Therefore I naught is equal to c. So I naught is equal to c is the equation number 3. From 2 and 3 we write, I is equal to, in place of I naught we write c, or in place of c we write I naught. So in equation number 2 c is there, so clearly we write I naught e power minus R by L into t. This is the initial solution for the given differential equation. Next problem. Find the equation of the curve passing through the point 1, 1, whose differential equation is y minus yx into dx plus x plus xy into dy is equal to 0. Here we are going to find the solution of the given differential equation. After that, we substitute the point 1, 1. So as usual, by using variable separable method, given differential equation is equation number 1, and we can separate the variables by y minus yx into dx is equal to minus x plus xy into dy. Okay. Now in this value, common y 1 minus x into dx. So in this we take common x values. So minus x into 1 plus y into dy. Now separating the variables. Separating the variables means the variables are separable. So all x and dx terms to one this side and all y and dy terms to this side. So 1 minus x by x into dx is equal to, here y can be transformed into this side, minus 1 plus y by y into dy. Okay. So now we are going to find the solution. That implies 1 by x minus x into dx is equal to minus 1 by y plus 1. 1 by y plus 1 into dy. Now integrating on both sides for solution. So integral 1 by x minus 1 into dx. So this term can be transformed to this side, plus, then only we have plus. Integral 1 by y plus 1 into dy is equal to c, means c is arbitrary constant for integration. Now integral 1 by x into dx minus integral 1 dx means dx plus integral 1 by y into dy plus integral 1 dy means dy is equal to c. Then clearly we have the value for this is log mod x minus integral dx value is x plus integral 1 by y with respect to y means derivative of y is 1. So that's why clearly we write ln y or ln mod y plus y is equal to c. Okay. Now that implies from these two ln a plus ln b form. That's why we write ln of ab means xy plus y minus x is equal to c. This is the solution. So in this solution already given that these curves passing through the point 1, 1. So in place of x we write 1, in place of y we write 1 also in this equation number 2. Then we have ln of 1 into 1 means 1 plus 1 minus 1 is equal to c. ln 1 value already we know 1, 0 plus 0 is equal to c. So c is equal to 0. So this is equation number 3. From 2 and 3 we have c is equal to 0.